All right. I think it's safe to start now, Harish. So, welcome everybody. Hello, and welcome to our second webinar for AI-HDL, Royal Harvard Design League. This is the second webinar in the series of webinars that we have planned for you to get you guys started with the competition. The competition itself starts in January, but these webinars are supposed to give you uh, the big picture idea, what we're trying to do, what is the challenge that you guys will be engaged with and participate in competition to complete. And we want to give you some sort of a starting point through these webinars so that you know where you're going and you have enough support to start the competition strong. So this is the second webinar in the webinar series that we have for you. There will be another webinar in December. We'll make an announcement for that later on. But just a quick note, remember if you have not signed up for the competition, register for the competition, make sure to do it before end of November, which is the current deadline that we have for registration. That way we have the numbers and we can make sure you all have a team to participate if you're participating as an individual, and make sure your team is good to go when we start the competition in January. Um, I don't want to take too much time to go on um, about the details of the next webinar because we have time. We'll release that information later on. But for today, in this webinar, our goal is to go over the overview, the recap, the AI-HDL's vision and the structure, and how the competition is going to be handled, and what the timeline is, again. And also we'll go into the details of what is the challenge that you guys will be um, trying to complete. In terms of the timeline, we will talk about different design phases that you guys will be engaged with, and um, we will give you a little bit more details compared to the last webinar, where we talked about the general idea of what AI-HDL is. Now we're talking about what the challenge is and what are the different phases that you will be engaged with. Go ahead, Harish. I will pass on to Harish, who is going to go over the details and introduce the competition challenge.
Mhm.
Thank you,
Thank
Harish.
you, Professor. Okay, so hey guys, welcome back to our webinar 2. So let's just go over what we discussed through in the last webinar about how our competition structure is. So currently, as we discussed, we have four phases with a base design expansion, your first phase, and then design evaluation, and then security evaluation, and then a chip tape out. So the first phase design is about it's about functionality. You're going to take the base processor, the RTL code. You're going to use your LLMs to generate AI generated code and test with it and add something new to it. In the second phase, we're going to be working on the PPA evaluation and optimization. So what's PPA? PPA is power, performance, and area where we want to optimize and increase their efficiency. So we want to make your chip fast, smaller, and energy efficient. Third phase, which is going to be held in March, is security. So right now, there's a lot of in this modern world, a fast chip isn't just enough. It has to be secure from other kinds of attacks, whether it be software attacks or hardware attacks. Here, we will be hacking your designs after you provide it to us after phase two, and well, uh, s- we'll be circling off vulnerabilities or leaks in your design and then send it back to you for you to evaluate it and fix it. The second one, after you're done with the security evaluation, is our phase four, which is the tape out. Here, this is like the final boss. That's all going to be totally through the RTL to GDS2 file. Now, the GDS2 file is a blueprint for manufacturing, which we provide to foundries and the chip manufacturers. This flow is totally from start of design all the way to the end of the design where you design a physical chip completely. Moving on. So mm, the key technologies we are using here. Um, the tool or the design base you're using is a RISC-V. Now, we've previously discussed RISC-V that it's an open source computer architecture that has been realized, that has been here for the past 15 years plus. Because it's open, you can easily look inside, modify it, and there have been various versions with all kinds of applications being used. Second, you'll be using AI. So this is the tool you'll be using for generating your RTL code and design process to help add a module to your RISC-V base. Third, we have our EDA tools, which is where you add all this and simulate it and synthesize it to create your physical chip. You'll get hands-on experience with both open source tools here and commercial tools, depending on which is more easier for you. This mix ensures that you're almost ready for the job market and your future is secure. Moving on. So methodology. AI first. I want to focus on this AI first methodology because this is unique to our league. There, the rule is simple. Hardware design must be generated only via prompting LLMs. What this means is scoring is based on the effective utilization of LLMs, on how you are prompting it and what is the kind of prompt message you're sending into your chat GPT or Gemini. The second point would be you can also give minor to manual corrections based on your knowledge to see if the code's correct, because not always is AI correct. So we always have to double check our code. Third, you have to submit your own prompt logs as part of your documentation, as it will be, we want to see through your thought process and how you engineered the prompt and how you plan to break the code with your AI. So this prompt engineering loop and AI first is a critical skill we are evaluating throughout the competition.
Let me just jump in here, Harish. So, kind of point of clarification here. Um, AI is not the best at doing the hardware design yet. So, there's a lot of research happening right now on how to improve AI tools, especially generative AI tools like large language models, to generate better hardware design. Um, so we know that there could be issues with the code, there could be bugs in the code. Now, we're allowing minor manual modifications if you know what you're doing, but our understanding is not everybody is familiar with hardware design who is participating in competition. AI can also help you find bugs. AI can also help you fix things. And we want to keep the focus on this uh, AI first because we want to make sure everybody um, can fix the code using AI tools, not necessarily knowing what the hardware design is. But if you're not really sure what you're doing, if you're not sure your code has an issue or not, you can go to the mentors. So the mentors will be available and help you figure out, okay, now you have your function in code, which, Harish is going to go over a lot more details. But I just wanted to highlight this, that you do have access to the mentors that could come in and help you figure out how can you fix the problems in your code using AI and LLMs, and not necessarily um, leave you on your own if you don't know how to fix the code. So make sure you're leveraging your options and resources as you're participating in this competition. Go ahead, Harish.
All right. Also, you can use your free AI while we are designing and in the prompting of your AI documentation. We would also encourage you to use all kinds of AI and also submit different kinds of prompts of different kinds of models. Moving on. So, what is the actual assignment? The challenge is we are customizing a RISC-V core. Now, in the last session, already we have discussed about what the RISC-V core is as an overview, but right now we're going to go ahead. We are going to provide you with a functional base RISC-V computer architecture processor core. Your primary task is you're going to be extending this core with a new custom functionality. It can be an application based off of it. It can be an optimization for the device itself. You're not building a CPU from scratch. You're just adding a module to an existing CPU, which will process it and run it. Instead, you're acting as the system architect, you could say, deciding what superpower you want to give to this processor. Second, you'll be focusing and modifying the optimizing course provided. Moving next. So, now that you see that the RISC-V can be a bit confusing when you're talking about modifying a CPU because it might feel too much for you. So we are thinking I will give you a small analogy, something that's easier to understand. The house analogy is where the core, you can think of the CPU as a house, and here you're just going to be building a new guest room. You do not need to rebuild a whole house completely again. That's not the task here. What you're building is a new guest room or a new room. Imagine that room you wanted, a den, anything, any kind of customization. You're going to connect it with that to this new house. And the simplicity is you can work on your own separate file with just the peripherals, which will be provided. And you don't have to trust the CPU logic. But the CPU logic will still be provided to you for you to kind of deep dig into it and kind of understand if you are curious enough. This helps us simplify the challenge while still having you focus on the main task. Moving next. Like we talked, the guest room specifications. Now, I told you about the guest room. So we'll be providing you with a base empty guest room or a full peripheral template. Now, what's a full peripheral template, you would ask, it is a module to be attached to the main core. So it has a data size of 32 bits, which is the full width of the CPU, and its complexity is high. That doesn't mean it's too hard to work on or it's too complex to work on. It can handle complex tasks too. For example, an AI accelerator, an encryption engine, and a math coprocessor, all are which do matrix math and encryption like AES and stuff. Here we can see that you can also develop your own module. Its complexity can be low, it can be medium, it can be high, but it's up to you as to what you want to decide. So the base system, what you'll be starting what will be provided to you. When you start on day one, you're not starting from zero. We are giving you a kit through our GitHub repository, which has the synthesizable Verilog RTL code, which has the base code for the core, the verification suite, which is a set of test benches for you to run your module that you attached against it to see if it's working or not. Documentation so that you know the full specs of what the design is, what you can do to add to it, what does each peripheral mean or each line of the code mean. And of course, this is all where it lives is in the GitHub repository, and tooling environment is going to be available to you as soon as you start the competition for the commercial tools. Whereas for the open source tools, you can always download it right now as a head. Start, you know, tweaking around with it in starting. So coming to the tools again. We are offering you a unique dual flow approach where you can use an open source tool flow, which is more flexible, or you can use the industry standard commercial tool flow. So this is the golden standard used by all other companies too. So it also helps to your practical skills. We have USYS and OpenRoad running our synthesis and RTL to GDS2 files for the open source flow, whereas Cadence has its own tool flow and Synopsys too. Moving on. Submissions. What do you submit? How do you submit and where do you submit? All your files are going to be submitted to GitHub, which means all your work can be managed via GitHub. You can download your code, you can clone your code locally, and that's where you commit your code, commit your changes. And we also request you to make sure you note down all your changes so we can kind of help score. It helps store your score on how it's being scored. Crucially, we also want final submissions for each phase using the GitHub tag, like DP1 submission, DP2 submission, which helps us, which makes it easy for us to decide the scores for you. This version will help you create a transparent design history and also teach you version control. Moving on, support systems. This is a competition, but it's also a community, and you're not alone. We have dedicated mentors, industrial experts, the Discord community, weekly check-ins to look in on you, and we also have a webinar 3 coming up for more information on how we are going to do a live demo of the tool. As we already talked in the last session too, dedicated mentors are the student mentors who will be meeting with you regularly through the weekly check-ins or Discord community, while we'll also have industry experts from Cadence and Synopsys help you out with their tool flows if you decide to choose their tools. Also, we can see, please join our Discord over here with the QR code. I'm just gonna give you a second so that you can take out your phones and scan it out.
And I just want to emphasize this information is available on AI-HDL website. And you throughout the presentation today, we'll have multiple opportunities for you to join the competition and the Discord channel. And later on, if you have any questions, feel free to reach out to us. If you are looking for a link and you're not finding it, let us know. We'll be happy to help you.
All right, then let's move on. Competition timeline. This is another thing you might have seen previously too, and it hasn't changed much since then. We are still in our webinars and tutorial phase, but our design phase starts from January 15th, where we move through 4 phases, which is expansion, optimization, security, and typeout. While these are going on, we also have milestone reviews at each month, at the end of each month. So the milestone reviews are like, imagine you're running into a design issue midway through your competition and your submission, and 2 weeks into the design phase, you're stuck or you're being looped around. We have dedicated hours where we are going to check in with each team to kind of help you, guide you, and put you back onto the right track or answer all your questions. And milestone reviews are going to be reviews as to seeing, checking how your progress is. Again, milestone reviews and office hours are not going to be counted towards your scoring and towards the design phase results. It's only being for helping you and providing more support for you guys. Moving on, let's talk about design phase 1 here. So, the base design expansion. Let's deep divide. So the base design expansion kicks off on January 15th. Your objective is to integrate a custom module, like we previously discussed, into the base RISC-V core, or build your own. This is where you build your own guest room. So what you deliver here is how the functionality works. We don't care if it is slow or big right now, because we are going to work on that in our design phase 2 for optimization. We just want to see that it runs successfully and it can pass through its operation completely. This establishes the baseline for the rest of your competition so that we're working off with an already functioning design. Here, the key concepts you're going to work with for those who are,
Sorry, Harish. Can you go
uh
back to the previous slide? I just want to emphasize something. Of course, the league starts on January 15, and you see the milestone review 2 weeks after. But just want to make sure you guys understand how things are going to work out, especially with the style of the competition. This is an asynchronous competition. So, like, we are providing feedback. We will provide help if you have those milestone reviews. submissions. And if you don't have those submissions, that's fine. There's no penalty necessarily if you're missing the submission of January 29th. Our goal is to be able to see your submissions and be able to help you get a complete design at the end. Uh, so January 15th we start. January 29th, about 2 weeks after, we have our first office hours or milestone review. But then you have about a week or two before the next phase start to complete your phase one. So it's not that within 2 weeks you should be done and everything should be ready. You'll have about a month for each phase to complete. That's our style that we are using this round for AI Hardware Design Link. Go ahead, Harish.
Mhm. Thank you. All right. So what are you going to do during this design phase is what you're going to talk here. Key concepts are RTL and synthesis. For those who are new to hardware, let's define what these concepts are. RTL is register transfer level. So your RTL code can be designed in Verilog or VHDL, and the process of putting in your RTL code, which is your Verilog code, into a synthesized logic gate is the process called synthesis, and that's how you perform synthesis. So the RTL code also describes the behavior of the signals, how the data moves from register to register, or how your operation works functionally. Synthesis takes this behavioral code, translates into a netlist or a map of logic gates, as we can see here in the picture. This means you can just write code. You can't just write code that runs in a simulator. It has to be synthesized and then converted into netlist, which can then be simulated and verified. So now that that's done, let's go back once again. So how does our process fit here? Um, in the design phase one, you're going to be prompting AI for your AI generated code, which is going to be in RTL and Verilog. Now you're going to use that and kind of push it through USys or the open source tools or Cadence tools to synthesize it and create a netlist. Once you're done with that, what it does is it verifies, and after that, you're going to verify functionality with another tool called Verilator, which is used for simulation and verification. And you repeat this process multiple times to kind of better make your to get your RTL code to run properly. And AI is going to be helping throughout with this, and we'll also have weekly mentor sessions to kind of help you out if you have questions regarding it. So let's talk about weekly goals. The first one is going to be your project kickoff and base integration. I would like you to kind of take this week to kind of think about what kind of a design you want to put. Because once you finalize your design, that's the design you're going to be sticking with all the way till the end of the competition. And you will have time to improve over it if you feel like your design is too hard for you to think. Just go ahead and make sure you can verify it completely. Once that's done, you can focus on how to build your design because you have plenty of time. But yeah, you're gonna develop your project plan and for your new module, and then you're gonna use LLMs to generate the Verilog code as we discussed, and a simple standalone test bench just for that module to see if the module is running. After that, we are gonna connect that test new module with a top level core where you'll be running another set of verification with test bench that we provide. In the week two, you can run the full simulations to it if you to ensure that nothing is broken and then run a baseline synthesis to get your initial PPA. As we discussed PPA results, the power, performance, and analysis. For more information on how we are going to get that done, we'll be discussing it more in webinar 3. Here, you'll also be fixing any bugs, cleaning your code, and then right after at the end of week two, we will have our office hours or mentor hour and milestone review. Here, we're just gonna check on over your progress, and you can also complete if you complete it and submit it earlier. That's even better. But we are also here to help you. going ahead, key tools. So we just talked about how we are going to be using what tools. And so as we talked, Yosis is the open source tool for synthesis where you convert your Verilog code to a netlist. And Verilator is another tool for simulating, which is to check whether your Verilog code is correct by converting it into C++ code and running a simulation. And to check your simulation results, GTK wave is the waveform where you will be visually viewing your wave outputs on your power and current to see how your design is running and also verify the output. Moving ahead. So, once you're done with all of this at the end of January, and here is how you're gonna put your submission. So, in your DP1 submission, you can submit it as an archive. You can submit it together as a GitHub repo. You'd want to put together your complete modified RISC-V core along with its test benches, which shows that it has passed it, and screenshots showing that the test benches or like your DP1 report with the full module package and how the test benches have provided passed, and then the baseline synthesis report, the PPA analysis report. Along with this, you're also going to be providing a separate document for LLM prompt logs and also a write-up of your design choice. All of this can be tagged on GitHub with a final commit tag as DP1 submission, and you're done with phase one. After you're done with phase one, there'll be a week's time where we'll be deciding how you're scored and what your scores are, and we'll be releasing it right before DP2. So let's go over the DP1 scoring rubric. The biggest chunk is module implementation, as that is the most important one, and we're also gonna score you or give you score based on how you've designed your module and what kind of application you've chosen for your module. So we've decided to put 30% for it. Verification has 25% to see if all the test benches have passed and if it actually works. 25% is for documentation, and it is pretty important because you need those prompt logs and we need to know all that information of how you're putting your project plan and block diagrams. Number 20 is the code quality and repository. So aside from your module implementation, this is how you're committing your GitHub code and how it is verify design structured. We'd also be checking your README page from your GitHub page to verify this. So it has 20%. Moving ahead, let's go through DP phase two.
Before that, Harish, can
Mhm.
you put yourself on Discord? Because a couple people there said
Oh,
you're not here yet because you're mute.
oh, one moment. Huh. I'm so sorry. I didn't notice that.
Okay, I mean, the recording will be available, so it's okay. Just
Yes.
moving forward, I just want to make sure that the voice
All
is.
right. Okay, guys.
Another thing,
So
if you have any
mhm.
questions regarding any of the design phases,
You can take your time here to put
yeah,
it and we can kind of address design phase questions. So let's take 5 minutes to address any questions regarding design phase one. And guys, you can also please send any.
yeah, you can put in the chat if you have any questions, and we'll address it. And if you don't know what kind of questions you should be asking, it's okay. We can always at the end we have a Q&A that we can address any of the concerns that you guys might have. And again, you have access to us through the Discord channel to ask any questions you have, and hopefully we'll be able to address it as soon as possible before the competition starts. I think, Harish, you can continue with
Mhm.
explaining design phase two. And
Yeah.
again, hopefully we can get.
We just have a few questions popped up right now. So yeah, if you don't have a team, don't worry. We will be assigning you a team based on your local region and your background. Not about the design phase, but for signing up, do we need to do that individually?
I'll
It would
address
work
some
if you. Mhm.
questions in chat. Don't worry about it. I would say
Okay.
continue with the design phase, and I'll address those in the chat.
All right. Let's go ahead. So, design phase two. This is going to be focusing on our design evaluation and PPA optimization. So, our design phase starts in February 12th, which is mid-February, sorry. But we're going to be focusing on PPA optimization, and you have 2 weeks again with your milestone review and office hours for us for our check-in. So, what we can see is objectives. Um, Take your functional design. You're going to take your functional design, DP1 design, and make it efficient, optimize for power, performance, and area. So the deliverable is your analysis, your microarchitectural tweaks, small tweaks, trade-offs, and your before and after analysis of how much optimization you kind of changed through your power, performance, and area. Moving ahead. Power. So the key concepts. What is PPA? It stands for power, performance, and area. Power, how much power your chip consumes. So the lower the power your consumption is, the better it is, and the more efficient your chip is. Performance, how fast your chip runs. So it shows us what the speed is, and higher frequency or a lower delay is always better, which shows lower latency and thus improves better optimization. Area. Now, we always know that in chip design, area has always been one of the major issues, with size becoming an issue even day by day. But here you're trying to compress your design as much as possible, and you're gonna see how small of an area you can provide for your design. So the iron triangle. There's a challenge called the iron triangle where improving all three at a time is a challenge. You can improve one performance, which will kind of impact others, power and area, but your objective is to find the best trade-off. So your objective is kind of finding the best middle point between these three, which is not harming each of the other aspects. So let's see, moving forward. After power, performance, and area, let's talk about how we are going to focus on. So for power and area, it is pretty simple. You just need to focus on your code. Whereas for performance, it takes us to two separate key concepts called STA and CG, which is static timing analysis and clock gating. So what are they? Static timing analysis is a way to calculate the speed of your chip without stimulating it. So you're not running a simulation, but you're running a simple software to run an analysis on your chip to see what your static timing path is. It finds the critical path, and it also finds the slowest path in your chain. If you want to run faster, you have to fix your critical path. So the critical path timing, the lesser it is, the better it is. Clock gating. This is another particular method to save power. It basically means turning off lights in the room when you're not using it. If a module is inactive, we cut the clock signal going to it so that there's no power being consumed by that specific module. This helps in kind of compartmentalizing where your power or your clock signal goes to. So no clock, which equals to no switching and no turning on of the module or no application being run, thus leading to no power consumed and no extra power being wasted. So these two are methods where you can help to improve the PPA analysis of your design. And again, how you're going to be doing this is you're still going to be using your design from you're going to use your DP1 design and run a full PPA analysis in your first week and get a baseline design as to what your PPA report is. And then you're going to create an optimization plan. So your once you got your PPA analysis report, you can see which sector you're weak in, which of the PPA aspects are lacking, whether it's power, performance, or area. And you're going to create an optimization plan to fix it. So maybe you need to fix your pipeline stages in the Verilog code to fix timing. You can simply use a prompt to see, I want to fix timing and these pipeline stages, can you find a way to reduce the amount of pipelining being happen? And AI would help you with it. Similarly, with clock gating or to fix power, you can use clock gating. Week two is where you can start running regression tests. Now that you kind of have your AI generated code, you can work on how to see if it is working, if the code is actually first you want to check if the code is functional and or not. Once it's functional, you want to see, you want to pull out its PPA analysis and see what the trade-off is, which part of your PPA aspect has improved, whether it is your power has improved or your performance, or has it been a decline. You'd want to generate all these reports and log them to show what your scale and how AI has been helping you. And finally, once you've gone through several tests and optimized your report, you want to generate your final PPA optimized reports. And then you want to create a before and after comparison report to show your improvements and then tag your DP to submission on GitHub. Right after this, we'll have our milestone review and office hours where we'll be reviewing how you have been prompting AI, especially in the sector of to optimize your design, and then how you are running the regression tests and simulation tests to check the PPA analysis. And for those who have been stuck in the stage, we'll also be conducting office hours to kind of guide you and push you in the right path again. And yeah, this is once you're done with this, this is going to be a wrap up for your design phase two. Moving ahead, what are you going to be submitting as your final developer? So the optimized Verilog code, we already have your original RTL module. Now you're gonna have your modified optimized PPA optimized module, and you're gonna tag it in. And then the final STA and PPA reports also included, and a comparison between your baseline PPA analysis from week one and a before and after comparison. Also a write-up of how you have gone ahead with kind of designing this throughout the weeks or throughout your run trials. And then also, what's more important is your design prompt logs. The LLM prompt logs are a must in each design phase and have to be included with each design submission. Finally, you can just commit this as the DV2 submission tag and you're done. Next, we have, let's talk about the scoring rubric. So we have 25% for 25% for performance and power optimization to see how you improved. And then the final results and reporting will be based on how much of an improvement has been going. So if the 25% for the performance optimization is the improvement in your timing and frequency as to what kind of methods you used and how you used it. Similarly, only in the aspect of power optimization of what kind of features you used for power saving and what kind of techniques you used, including clock gating. In the final results, you would want to show the quality of before and after comparison. Now, this comparison is going to be a full trade-off between all three aspects, power, performance, and area from your design phase one and design phase two. Trade-off justification. So a clear documentation of what and how you made your certain PPA trade-offs better. And then the baseline PPA analysis is the thorough analysis of the design and clear identification of bottlenecks. With this, your DP scoring rubric would be done and your DP phase two will be done. Moving ahead, we have the DP phase three. So the DP phase three is the security evaluation and threat mitigation. What are you going to be doing in this phase is it is often the most eye-opening phase for students because most students haven't even come close. to learning about security evaluation and chip design, even through college. Here, your objective is you hack your own design and then patch it. A security assessment and its countermeasures, what you implemented. We want you to think like where your design is vulnerable and see how it is using AI. You can also ask AI to kind of verify your design and see for vulnerabilities. And yeah, DP phase 3 starts in March 12th. And again, 2 weeks later, we have our milestone review and office hours. So we have this trend of 2 weeks check in with each phase. So what are the key concepts? The key concepts here we are focusing on is what is hardware security? We all know software security and we all have antivirus softwares for our laptops, PCs, and even mobiles these days. But we know the importance of software security. But many people don't understand the importance of hardware security and hardware vulnerabilities. So, hardware vulnerability is like a flaw in the logic itself. When you're prompting AI to generate your LLM code, you can you might have faced when you're generating code with AI. It's not always correct, or there might be certain errors that the AI couldn't read properly and has provided a half finished code. It is not going to be a software bug, but it's a weakness in the RTL logic itself. Unlike software, you cannot patch hardware once the chip is printed, and hardware bugs cannot be addressed post-fabrication. So this is one important thing where hardware security comes way much into importance right during chip design and the design phases. So we use the CWE database, which is the Common Weakness Enumeration. It's a database with the list of hardware and software vulnerabilities in chips and various modules. We use the CVE databases to identify these, and you will look for these things like side channel attacks, hardware trojans, debug misuse, and buffer overflows, leaking data via power usage and stuff. Your team, again, your objective here is you will be auditing your own design, checking for any flaws, recording those flaws, and then you're also going to be providing a list of how you addressed those flaws and what implementation has been done to fix them moving forward. So, what are our weekly goals going to be like for this phase? Again, we have it divided into weeks, where the first week you can just create a security review document and then list the potential vulnerabilities in design and also develop a mitigation plan. For you must implement at least one of these major countermeasures. For example, adding privilege checks so unauthorized users can't access your encryption engine if you're designing an encryption engine like we discussed in the start and other stuff. In the week two, you're gonna work on validation. So now that you kind of implemented the design, you have to kind of check if the design now, secure design is working properly or not. You have to test your security feature. How are you gonna prove it works? You're gonna run it. You're gonna run ignition tests. Excuse me, one moment. Yeah. So, sorry about that. Again, back to week two, validation and hardening. So now that you're running your security feature, you want to see how do you prove it works? How you prove it works is after implementing the secure function, you're going to check your PPA. Has it went up again? Has it same the stay? Has it decreased even better? Did it make it better? Did adding security make your chip huge or slow? That's a trade-off you need to document and write in your final security report. And you can also tag your third RTL code for submission. With this stage, after this, we have our milestone reviews and office hours where we will be checking on so here we'll be helping you out with discovering if the major security countermeasures. So you might have several countermeasures or several vulnerabilities. And some of them might be minor vulnerabilities, some might be very major vulnerabilities where it is a threat to the code itself. And so we're going to help categorize those with you and kind of see how many of you have discovered them through the milestone reviews. And in the office hours, we're also going to help you to push to what kind to see what kind of CWEs you can look for in your design, or so certain application designs might have certain CWEs, certain specific vulnerabilities like power, like side channel attacks and being too weak for that. Or some might have another issue. Suppose you're designing an encryption engine, then you might want to see if your encryption isn't being broken through or can't be cracked midway through. Moving ahead. So now that you're done with your DP3, what are you going to be submitting? Again, your secure RTL code, the third version of your modified, hardened, and functionally correct Verilog code, and then a security evaluation report. So your vulnerability assessment from week one of this design phase, a detailed explanation of what countermeasures you implemented and whether they're major and minor, and then the validation results to prove how you fixed each of those and which ones you've addressed. The PPA overhead analysis, which is the cost of your security feature. So now that you added this feature, there's definitely going to be a change in how much power is being consumed, or if the performance drops a bit, and if the area has increased. This is an important phase where you're going to check through all of those. And again, you're going to commit your final GitHub submission as DP3 submission. Moving ahead, let's go through the scoring rubric. So again, the security feature implementation here has a huge chunk for 30%. This is because this is the main function and the main motive of this design phase, to check if your security feature has been implemented correctly, and then followed by validation and hardening to verify whether your security feature is working correctly and proof that it is working. The security assessment is your assessment of your own design. So in the scoring, we are also going to be going through your design and check for vulnerabilities side by side to see how many of the vulnerabilities you caught that we couldn't, or how many of you those you couldn't catch that we could. So here it's like going to be the number of security assessments in your design and how many you could address or how many that you could have predict catch. And in the documentation here, we want a clear DP3 report with a detailed explanation of mitigation and the trade-offs. And finally, the design stability or the PPA effort. The functional correctness is preserved, and if your tests are all clean and working perfect. Moving next, we have the design 4, which is going to be the final phase of this design. So here we have the netlist to chip tape out. Now, DP4 is our final design phase, where if previously we've been working with just synthesizing and optimizing our RTL code, here in this phase, we are going to work with taking your secure optimized RTL code and turning it into a GDS2 file. This is the backend flow. This is where code becomes physics and is ready to be printed. Here, again, our design phase 4 starts in April 9th, which is mid-April, and then we have an office hours 2 weeks later to verify whether your design is correct or not with milestone review 4. Moving ahead. So, what are the key concepts? The backend flow here, when you're designing through RTL to GDS2, it goes through three major flow steps, which is floor planning, place and route, P&R, DRC, which is design rule checks, and LVS, which is layout versus schematic. So this process completely is known as sign off. What is floor planning? Floor planning is where you decide where your guest room goes in the house, or physically on the chip where it is going to be placed. to optimize for area. This is where you can better optimize your area after your digital design is done. So now that we're talking again about optimizing area, how is it different from the area optimization we did earlier? So in the previous DAP phase two, if we've designed, and the goal of that DPA design phase was to optimize your particular module to reduce the area, improve power and performance. And that's going to be the small module. Whereas in this DP phase 4, in through floor planning, that small module, we are going to see and define where it goes in your chip floor plan to kind of better fit it with all the logic blocks, power grids, and IO pins being placed. So this is where your module is going to be placed with the CPU core on your physical chip design. This also helps in how you're going to be utilizing your design and how it is being optimized. Place and route. So after you're done with defining where the chip goes, the placement and routing is it helps place all of your standard cells onto the floor plan. Now it's like imagine you have your house, you designed a floor, you have a design, you know where it wants to go. Now through place and route is where all those cells go, and routing is where it connects with all those IO blocks, IO pins, logic blocks, and the power outputs. So this is where the floor plan and place and route becomes together into one chip. Now that the chip is ready, you have to run DRC and LVS to ensure that the factory can manufacture the chip. So what is design DRC? It's a design rule check. So imagine you're designing something. You're bound to have certain design constraints or rules to follow to kind of design it within the boundaries of it so that you want to manufacture it. This ensures your layout is manufacturable. That means it has a rule book where it checks through everything, including your area, your layout size, how you're routing your wires and stuff. LVS is another method where it takes your layout and your schematic, which is generated from the synthesis process, and it kind of compares if the picture matches the code. If it matches, then the DRC and LVS clean comes out and it shows that you have zero errors, which means it is finally ready to being shipped off to the manufacturer. So what are weekly goals going to be look like? First, you're going to run your final synthesis with your optimized, hardened, and secure RTL code. You're going to create your chips for plan, include the power grid system, all of that in the first week, and check it. Now, there's this saying that DRC and LVS is one of the trickiest to crack in chip design because you go through the layout, you run your DRC, it goes through a certain process for a certain time, and the time is not too short if your design's too complex. Once that's done, if you have an error, you have to go back again to your layout, to your drawing board, fix those errors, come back, recheck it again. It's going to be a process where you're going to go from your layout to DRC and back and through until you find kind of optimized and passed your DRC check. Once that's done, your goal is to, once you're done with the DRC check, it should be pretty easy to complete your LVS check, as that is pretty simple. And this is the bar for the manufacturer chip. Once that's done, you extract your GDS2 file after the LVS and package it. How we are going to be doing that is I will be giving you a detailed explanation for that in the webinar 3, as it's a detailed process and requires plenty of time. So with this, at the end of your whole competition journey from DP1 to DP4, you're going to write a final comprehensive project report style to explain what you've gone through, what you updated through each design phases, and then you're also gonna attach your prompt logs for each design phase together and your PPA analysis reports for each phase, and kind of put it together into one huge document for us to go through. This helps us in better finalizing the winners to see what kind of process you went through. Finally, we have the DP phase, final deliverables. What are you going to be submitting? you're going to be submitting your final GDS2 file, which is the manufacturable layout of your chip, which we are going to be sending it out to manufacturers, and your sign-off reports, which shows that you have a clean DRC and LVS, and the final static timing analysis reports along with your PPA analysis reports. And then the final project report, as we discussed earlier, and you're going to tag all these three together into the final DP4 submission. So, how are we going to score for this? Physical design. So, before DRC and LVS is the process of creating your layout and floor planning and PNR, which is placing and routing. We've placed a major 30% chunk for it because this is where you have to go back from your DRC again to check it is working and kind of redraw it, redesign it properly, and make sure it is clean. And then the sign of quality, 20% for the DRC and LVS clean reports, which shows that we do not need to go back to the design and fix it. It is already ready to be shipped out, and we just need to check it again. The timing closure and PPA analysis, your final PPA metrics and STA reports, which have been well documented as we talked before. And 20% goes to your submission package, which is the submission for the complete GDS2 file along with its netlist constraints and PDK and the final comprehensive report. Finally, we have 10% for how you presented and clarity of your whole repo organization and project story, which is your project documentation. With that, we are done with our design phase 4 and the end of the competition. So now that we are at the end, how do we pick the winners? So it's going to be a cumulative weighted score. And as we see here, we have a increase of weights as we go from DP1 to DP4. And so we have 20% here for DP1, 25% for DP2, 25% for DP3, and 30% for DP4. The reason we wanted to put it because everyone is starting new in DP phase 1 and are learning everything and slowly want to go. So we've kind of reduced the weightage for DP1 so that everyone can kind of go through it. And then for DP4, which is our end of the competition, we have raised the weights over there so that we wanted to see which team has the best chip design and the final layout and the final DRC runs. And so consistency matters. You have your time throughout January to April, and you have enough time to work on the code in your own leisure time with a lot with the office hours and milestone reviews every DP phase. So the top three winners will be recognized with the highest cumulative score, and the top performing team will win a chip tape out. Going on. So, um, bonus opportunities and penalties. So we'll also penalize you for improper code and improper submissions. And your bonus examples can be exceptional use of AI and LMs, implementation of an advanced feature in your security features, or contributing a bug fix or a feature back. Major penalties can be like a design that doesn't simulate or synthesize at final submission, failing to submit a clean GDS2 file, failing the DRC or LVS checks because it will not become a manufacturer design again, incomplete documentation, which again I cannot be enough critical, but the missing AI prompt logs. So those will also be penalized as it is quite important. So your journey starts now. If you, I know all of you guys have registered, but if you need to team, you can pull your friends in and also register again as a team. The registration closed this November at the end, November 30th. And we have our next webinar, which is webinar 3 being held on December 18th. So what this webinar is going to be about is the initial RTL demo and the tool setup and environment and a live demo of how we are going to do a sample run of a base core with an additional module which we are designing all the way from design phase 1 to design phase 4. So you can have an example to know what you're working on. And also, please join the Discord. So this is where you're going to be interacting with mentors and other participants and also finding teams. So do not forget to join us on Discord. And now we can be open to questions.
I just want to thank you, Hari, so much for the presentation and going through all the design phase and details, and hopefully that is clear for all the participants. I just wanted to emphasize this. Once you register for the competition, make sure you're putting in your institutional email address, like for example, in the United States, we have the EDU email address, and I mean, around the world, you all have institutions that you're participating from. So make sure the email that you provide as your email is your institution email. It's not a Gmail, it's not a Yahoo, it's not a personal email. If you have submitted your registration with a personal email, make sure you're reaching out to Harish and updating that email address so it's institutional email address. The main reason for that is all participants need to be verified, and one of the ways we are verifying participants is through your institutional email address. So if you do not have an institutional email address, you also need to reach out to us and let us know so that we can identify a way to move forward for you. So make sure again to register with your institutional email address, an official email address. Now, I've seen some questions and I've responded to some questions in the chat, but let's look at some of the other questions that are coming in. Um, so I'll just go from the top and go over some of the questions. Of course, the meeting is recorded and the recording will be available on the AI-HDL website under timeline. There's the webinar and then there's a hyperlink. So if you click on once the webinar is done, the link turns from registration to and it becomes a video that is linked to a YouTube video, which is the recording of the webinar. So make sure you check the website frequently to see those updates. I see other questions about can I take help from AI in the design phase? Yeah, that's the whole purpose. You're going to be using AI to do the design with minimal manual modifications. About signing up. So if you're part of a team, everybody in the team need to register. So all participants in a team need to register separately. So what you would do is register yourself, and then there are spots where you can put the information of your teammates. So each member of each team has to register separately. So don't say like, my one person in my team has registered, so I'm fine. No, we need everybody to register. And we have to verify every participant to make sure all participants that are active, engaged in this competition are verified. There was a question about IP and patent protection. So there's no IP, there's no patent protection. Everything is open source, and everything we do is going to be released as open source at the end as well. So we will not be developing any specific IP, and whatever you're developing is as part of a competition. So I hope that clarifies it. Let's see. Yeah, if you joined late to this meeting, that's fine. Again, the recording will be available, so no worries there. Um, are all submissions done on GitHub? Yes. So all submissions are going to be tagged separately, as Harish mentioned, and will be the submission will be made on GitHub, and that's how we will be evaluating the submissions as well. So there's some information about the submission process in webinar one, which I encourage you to go and watch that webinar video if you have further questions on that submission process. But then down the line, also in the next webinar, we'll have some more information for you on how
Yeah. we'll also do a demo of how we are going to commit to your repo and a small demo on how we are going to submit.
Yeah. So I still have a question about previous seminar. Preferably each group has a mentor from their own university. Does that mean we have to look for a mentor ourselves? No. So ideally, what we are doing is all the institutions that are participating will be reaching out, and then hopefully we'll be able to arrange to have a mentor locally assigned for you. However, you will have access to the primary mentors that we have, Harish and Viramani, here on this call right now. But we have a team of mentors that are available. However, given the number of participants of the competition and the global aspect of it, with the difference in the time zones and everything, it will be difficult to um, maintain, proper connection and contact with all the mentors that are in the United States if you're from other parts of the world. So what we want to do is hopefully we can get some local mentorship so that you have, um, someone locally available to you to help you guide you through this competition. However, the main mentors that we have for the competition will be able to help you. All you need to do is join the Discord and post your question on Discord, and our mentors will get back to you as soon as possible. Um, your team will be assigned to a mentor. So, correct. So, another question that is good here is you have access to all mentors, but then you will have a dedicated mentor that will be working with your team. So, that's also an option that we have. How big can the team be? So the teams are between 3 to 5 members. So minimum of three, maximum of five, and they all have to be from the same level. So for example, first of all, everybody has to be a student, enrolled and in classes, and you're participating from your institution. So you have to be either undergraduate student or graduate student. In the United States, we have the community colleges also involved. But the idea is you're in the team with the people from the same degree, or like same level, not the same degree. So let's say like you can have someone from, let's say, electrical engineering background, someone from like business administration, someone from nursing, maybe. That's not a limitation. However, the limitation comes in that if you're an undergraduate, you only can team up with undergraduates. If you're a grad student, you can only team up with grad students. So that's the only limitation that we have for the competition in terms of forming a team. Um, the teams, if you're a part of a team, fantastic. If you're not part of a team and registering it as individual, once the registration closes on November 30th, as you see on the screen, we will be going through the registrations and filtering through and verifying the participants. And once all the participants are verified, the next step is to team the individual registrants. So what we will do is go through the list and based on registration from your institutions, we'll be teaming you up with people from your institutions locally. Um, or we'll be possibly adding you to a team, or we'll be forming a team that will be you and some other folks from your institution. So stay tuned for that. That's going to happen in December. Once the registration closes, we'll have more information to share. And again, before, like hopefully around the time with webinar 3, we'll be releasing information about the teams um, and like more information about how you could get in touch with your mentor and so on. List of a specific open source tool they'll be setting up for the environment. So there's a lot of different tools, of course, that Harish put the names in the chat. However, watching the demo, it will help clarify some things. Besides that, what we are trying to do also is provide some video tutorials on how to get the tools set up and how to use these tools. So don't worry about that. We have you covered. So stay tuned for more information. Like everything will be available through AI-HDL website. There's different tabs in there. There's educational resources where we will be providing all the videos and tutorials. And there's the timeline where we are putting all the information about the webinar recordings and so on. So make sure you check the website regularly. Um, date for the beginning of the competition. So the timeline is mentioned on the website, and Harish also covered it today in this webinar. The competition starts January 15th, and that's going to be the start of our first design phase. The timeline is mentioned in the webinar, so I will refer you back to the webinar slide deck and recording. So if you missed that, make sure you watch this. And also, it's available on AI-HDL website with under timeline tab. So make sure you check that out. Does every individual in the team submit the project or one person submits on behalf of the team? So great question, Laura. So once you form a team, one person will be your lead for each team. So we will, once the teams are formed, we'll be reaching out to you and letting you know who will be the lead for your team. So if you have a preference, you can let us know. Otherwise, we will make sure that each team has one team lead which is from your team. One person will be doing all the GitHub submissions, and that will be our point of contact. So from each team, we need one person to lead the team, and that will be our point of contact to get the resources to your team and also answer any questions you might have. And in case you have any questions regarding the tools that you're using, there's any troubleshooting issues, that person who is the team lead for you will be asking those questions from our mentors. We'll be relaying that question to our sponsors like Cadence, Synopsys, and we'll be addressing those. We'll get help from those folks, the professionals, to address your questions. Um, Please share the link to webinar. So yeah, so thank you very much for putting that. Although, as I said, all the links are available on AI-HDL website. So Harish, would you mind actually sharing your screen? Like go to AI-HDL website and share your screen so you can show where students can find, participants can find the link to webinars. So if you're 2% and my friend from same campus and we want to work together with a team, how should we register? So again, teams are 3 to 5 members. If you do not have a third member based on individual one person to your team to make you at least three. Our ideally, we want each team to have 5 members to have enough support and make sure you can complete the competition within the time that we have. So if you scroll down, go to the timeline tab right there. So if you see October 30, that link is going to be the link to the webinar one and go back actually. And webinar two, you can see if you click on webinar two right now, it takes you to the registration page for the webinar two. Once we're done with this recording, that link will change into the video on YouTube. So we'll be posting this video on YouTube and then we'll give a link on this page. So you have access to that and you can see the entire competition timeline as you see on the screen. So that will be the timeline that we'll be following for the competition. And we don't anticipate extending any of these time deadlines. So our goal is to hit every milestone on this timeline that we've set. I think I covered all the questions I see in the chat. So are there any other questions that you guys have? Please feel free to put it in the chat and I will go through and I'll make sure that I'm addressing all of them. Um, just to recap some of the common questions, everybody in each team has to register. Teams are 3 to 5 members, and these are all information available on the website. The recording will be available on AI-HDL website. Make sure to check it frequently. Under educational resources, so there was a question about not having enough knowledge on RTL, and will we provide more information? So if you go down in the educational resources there, so there's a lot of material that you can you have access to. Like, there's a lot of training educational material. And then if you go to Introduction to Hardware and Semiconductors, the second tab. So there's like a bunch of videos here that we have provided to you. So like Introduction to Verilog is one of the videos that is like additional videos. You can see that. And then if you go to how to use AI to design hardware, there's some other resources and additional videos. Now, these are just a few, and we're adding to this list. And there's some also tutorials that for each design phase we'll be providing a video, a short video that would help you navigate through the competition, each design phase of the competition. Um, so I refer the questions about the timeline and about the details of the competition to the website. Make sure you check the website, all the information about the timeline, about when the competition starts. Um, it is provided there. The link to the Discord channel is there, and the link to the GitHub repo is also there. So make sure you are checking the website frequently for more information. Let's see. Could you Oh yeah, my group mates and I have exams in January. Is it a problem if the group doesn't work on the competition much during this period? So as I said, this is an asynchronous competition, and thanks for the question. This is a asynchronous competition, meaning that there's these are the timeline that we have provided is the timeline that we're going to go based on releasing the design phases and also providing the webinar information, tutorial information, and help for the teams. However, you can work on your own time. You can work on your own schedule. You can make it match your own schedule. You can work anytime, anywhere. There's no limitations on that. And as I said, the only submission that we will be scoring as the final is going to be your final submission, but we require all the design phases to be done. So we have a separate scoring rubric for each design phase. And our goal is for you to complete each design phase separately. So you, for example, you can submit all design phases at once, not a problem. That's also a possibility. And we'll be scoring it at the end and give you a score, a final score. So if you cannot work in January, that's fine. You can catch up later on and make sure you're completing the tasks on time before the end of competition. Hopefully that answers your question. Could you elaborate on what constitutes an advanced feature that would qualify for bonus points? For instance, does it need to be a new module or can it be? So I mean, I'll let Harish kind of cover that later, extend what I'm saying, but the idea here is you you're going to be given a base design where you're not changing anything in that base design. There will be the space design is your core, which everybody will start with. Then the space design has some peripherals that you can implement. Now you can add features to the space design, and those features that you add, it's not necessarily a bonus point, it's technically part of design phase one. So you will be designing an additional feature, and that could be, for example, an accelerator. It could be simply another simple core, which will provide more information in the demo that we are preparing for you for the next webinar. Like an example that you can see actually, um, like what would that look like? A similar way of seeing that when we say additional module, what do we mean by that? So we show an example in the next webinar, and then you will hopefully clarify things and give you a better idea. And then, of course, for optimization, you're using AI also for optimization and improving the quality of your design, right? So um, we'll provide more tutorials and clarification later on. Harish, do you have anything to add?
Yeah, so bonus points could be like optimizing techniques to your new module and security features, or an exemplary security feature, something like that. It can be related from each bonus, each of those design phases, where in the design phase one, maybe if you have a new module or you're using a very complex module which is totally new and separate, it can be qualified for a bonus point, and then in the optimization technique, it can be qualified for a bonus point in the design phase two on what kind of an optimization technique you're using. Again, in design phase three, security vulnerabilities you find and security features, those are also something. So in the security vulnerabilities, if you can find security vulnerabilities that we can't find in the while we are verifying your secure design, then that would be, and you found a security vulnerability within your own design that hasn't been found when we've been scoring it, that can lead to a bonus point and stuff like that.
Thank you, Harish. All right. Any other questions? Feel free to put in the chat, and I still am navigating, see if there's any new questions coming out. So I see a question for security review document design phase three. Are we expected to follow a specific format, or is a simple list of identified CWE sufficient? I relied on Harish to respond to this.
So regarding the specific format, we will be sending you a list of CVs related to the Risk 5 core and other modules. And based on that, you can kind of verify it, or you can also still go onto the CWE website to search for more CWEs. And yeah, you can reach out to your mentors through Discord, which is where we are going to conduct all of our competition's official communication. So please join Discord.
Yeah, so Laura, as I mentioned, you need to join Discord as a participant, and then in the Discord is where you can reach to mentors and have a direct link and ask questions anytime. There was a comment about saying that my friend and I are from same institution and we'll be competing together. Please do not assign anyone. So here's the thing. The teams need to be 3 to 5 members. So you can ideally find another person to join your team from your institutions and make it 3, and then that's fine with us. But if you have 2, then we'll need to add one member, and we'll be adding a member from your institution, not from an external institution. So ideally, we want you to tell us who you want to be on the same team with. However, if your team doesn't have enough team members, we'll need to assign one to you, so that we can make sure each team is 3 to 5 members at least. And that would, there's a reason it's all 3 to 5 members set up, based on our previous version that we ran and based on the experience that we have gathered through the pilot program that we had this past iteration of this competition. So it is required to have 3 to 5 members per team. And if you are not having 3 to 5 members, then we will be assigning another member to your team who is from your own institution, is not from an external institution or from even in the same country. That's not what we're doing. We're doing the same institution. For the backend flow, design phase 4 execution, are we expected to use a unified script makefile to manage the data passing and constraint conversion between the synthesis tool and the physical design tool? Or will we manually handle intermediate files like the netlist and timing constraint? Harish?
So again, it all depends on how you want to design. We are open. We are gonna just let students handle intermediate files like netlists and timing constraints. But if you can create a unified script on a makefile to manage all the data passing, that would be good too. Whatever would help you out, and it will be scored accordingly.
Hopefully that answers David's question. Let us know if you have any follow-ups. We still have time to address any other questions you guys may have. So please feel free to put any other questions in the chat and we'll address those. I don't see any other questions coming in the chat. I have email regarding research. Yeah, so anything related to the competition, please. If you have any questions other than that, can discuss it at the time and offline. I see another question might have been discussed already. In case that's fine. Groups get in touch with the sponsor at any point. So, yeah, so your connection with the sponsors are happening through the mentors of the competition. So you will not be um, like the mentors will join potentially during office hours, and that's where you can potentially ask questions from the industry mentors. But most of your interactions will be with our AI-HDL mentors, and the AI-HDL mentors will be your connection and link to the industry mentors. Our goal is to provide access to industry mentors, but obviously that's there's many participants here, and the time that our mentors have are very limited. So to ensure effective communication, and also make sure you guys get the adequate support that you need. Um, we have provided this hierarchical approach where uh, all your questions will come in and our mentor will try to address those, and any questions that would relate to anything like tool related, for example, for cadence or synopsis, as well as ARM, will be asking those folks to come in and help you guys and give answers to your questions. So um, will be you'll be in touch with the mentors, but the structure is a bit different. It's not necessarily a direct link. Our goal is to provide that direct link, but might not be a possibility at all times. So it's not like constant communication. However, we do have those monthly office hours where we're hoping that our mentors will be available from industry sponsors as well. So this is really up to you. I see a question about how many hours per week should a team dedicate to ensure success in the competition. So it's really up to you. We've provided that estimate that we have on the website about the weekly commitment right below the timeline. So you can see about 1 hour of league meetings every week and about 5 hours of project work time, which if divided by 5 members in your team will be 1 hour each. More or less. So that would be enough, in my opinion, to get you guys to good level and make sure you're completing the successfully competing in competition. Um, However, it's really up to you. Like you can spend like 20 hours a week, you can spend like 2 hours a week. It's not necessarily, we're not setting a schedule for you. We are providing a suggestion of having a 1 hour meeting for each team. It's helpful to get you guys all on the same page. And spending 5 hours of project work time, like about an hour per member, it's really doable. And I think it's possible to get things done with this kind of scheduling or um, having your team work together about like 5 hours a week. I think that should be fine. From your experience, what is the biggest mistake teams make when collaborating on large scale AI systems, and how can early stage developers avoid it? Um, I mean, there's so many things that we can discuss in this for this question, but communication, I think, is key. Each team, you'll have to be able to communicate effectively and make sure everybody in your team is aware of what you are doing, what you're working on, and be able to have a central place where it's going to be your GitHub repo where everybody can see all the resources of your project, can commit resources to your project, and be able to see and have visibility to the code that each person is writing or the work that each person is doing. Now, of course, um, collaboration, regardless whether you're using an AI system or not, is not like different really. It's technically using different tools, and as a team, you will need to work together, right? So I would say make sure each person is aware of what the role is in the team. You can assign roles to each team member and make sure each person knows what that role is through communication, effective communication, and have one person as your team lead who will be leading your team and making sure everything is on the schedule, every submission is happening on time, and you know, verify everything. In case that your team runs into a problem, reach out to the mentor and as soon as possible, so you have ample time to uh, get your response and fix things that could be going wrong. So, I mean, working as a team could be sometimes challenging as well because some folks might do more than the others, but it's really we are relying on you to manage your time and your team, and we are here to help you navigate through the competition. So um, a lot of the team related question, the dynamic it relates to who is on your team. And I recommend you team up with folks that are from your same institution because of that, because you're locally there and you can meet in person, have those meetings in person. It helps you also build a sense of team and make sure you're um, communicating effectively. So that's really key, I believe, in my opinion. And be respectful towards each other, right? So, and be understanding of each other. Um, here, the goal is to learn and have fun. And as long as we are learning and we're having fun, I think we're achieving the goal for this competition. And if you win, fantastic. But in my opinion, everybody is winning at the end of this competition because you're learning skill sets that are really helpful for your future and for your future career. So I highly encourage you to engage as much as you can with this competition and learn from what we have prepared for you. Because at the end of the day, I mean, I myself, I didn't have this opportunity when I was a student sitting in your seats. So now that we can provide this opportunity for you, I think you should seize this moment and capture this uh, opportunity. So let's see. As per your suggestion, I think team with two members will be fine. So again, it is a requirement to have at least three. So if you have two members, another member will be assigned to your team at least. Again, if you don't want to do that, I highly recommend find another person. Otherwise, um, it is a requirement. We cannot change the requirement for the competition. I'm sorry, but that's just how things are going to be. Any other questions? Maybe 5 more minutes, and let's see if you get any more questions within the next 5 minutes. We'll address, and otherwise, I guess we can conclude. Yeah, again, make sure you join the Discord. The QR code is on the screen, and that's your direct link to ask any questions. Um, Technically, if we don't have an active webinar that and you have a question you want to ask, Discord is the best place to ask those questions. We'll make sure you get your answers quickly. Everyone who joined the competition will get a certificate. So that's what we're working on, Rakib. So that's one of the things that we're working on is the tutorials that we are developing and going through the competition and learning the contents. Our partner industry partners, we're working together to see if we can make that happen. So that's in the works. And I cannot say yes or no to that right now, but I would love to do that. So I'm working towards it. So hopefully we can get a certificate for all the participants that are actively engaged in the competition. So if you are top three in each of the category divisions, whether it's undergraduate or graduate division, you will receive a certificate. But for all the participants, that's something that we're working with our industry sponsors to see if we can make that happen. So I don't have a yes or no answer for you right now. Hopefully, we'll have more information later on. And that information also will be available on AI-HDL website. If anything changes, we'll make that announcement in our future webinars. Any other questions, guys? I also want to highlight, we want you to succeed. We want you to win. Um, our goal is for you to complete this because um, the main purpose for us to put all of this together is to bring students who are interested in the topic and then teach them the basic skills and the basic knowledge they need to dig deeper into this topic of hardware design. And the benefit of AI tools and the advanced in AI has helped us to be able to provide this opportunity for anyone with any background to come and contribute and learn. And through this competition, which is supposed to be fun and engaging, learn a skill set that will be very useful for your future career. And the semiconductor industry is growing everywhere, all around the world. And having participated in this competition, it would add valuable skill set to your um, resume that you could use to help you find better jobs and better career pathways in the future. So we're excited that you guys are participating. We're really happy that we have um, so many registrations that are coming in still, and we're excited to work with you guys and make sure you are learning something really useful for your future. So the question about the winner being selected, so we'll be recognizing the top three teams from each division, so the undergraduate and graduate division. And the way we do that is based on the scoring rubric for each design phase that Harish shared in this webinar. And if you missed it, this webinar again, the recording will be available on our HDL website. But based on the rubric, the scoring rubric, will be scoring each team's submission, and you'll be ranked within a table. For each division. And once that ranking is in, we can define who is the winner. Now, currently, we'll have one ultimate winner whose design will be fabricated. But again, we're working with our industry sponsors to see if we can increase the number of folks that will be able to get that chip tape out and fabrication. So um, ultimately, the competition will have one winner combined from undergraduate and graduate. However, top three teams in each category will be recognized as winners. And one major winner, which will be the best design overall across the undergraduate and graduate. And just to give you a kind of like taste of this, so the team that won last round was actually an undergraduate team, and they won the undergraduate and the graduate combined. So um, we're going to do the same thing now, and then hopefully, fingers crossed, if we are able to provide a winning opportunity for like each division to have the top team in each division to have the tape out, that'll be ideal scenario. However, as of right now, that's not a guarantee. We're working with our sponsors to see if we can make it happen. So stay tuned for more information on that. But as of right now, the process of picking the champion or the winner is going to be based on the scoring rubric Harish mentioned for each design phase. And at the end, there'll be a table for each division. Any final thoughts from you, Harish, and anybody else also in the chat? Please feel free to put any of your final questions.
So yeah, everyone just be stay tuned to for the next webinar where we'll be discussing a live example for of the whole competition. So I will be running an example of all the design phases from the start to a tape out, so that you have and we can answer all your questions regarding to the design challenge.
All right, maybe um, I think that's pretty much it. I don't see any new questions coming in. And again, you have Discord channel available. You can send us questions anytime of the day. Uh, I'm up usually late, so you might get an answer from me like 3 a.m. I mean, my time, but hopefully we'll be able to get your questions answered um, as fast as possible. Well, I think it's safe to say it's a wrap for this webinar. Thanks everybody for joining us, and hope to see you in the next webinar. And make sure if you haven't registered yet, make sure to complete your registration, join our Discord, and let us know if you have any questions. We'll be happy to answer those. Thanks again for participating. We're excited, and hopefully you will learn a lot. Thank you, everybody.